Hello everybody, today is April 14th, 2020, and today we are going to continue our way through Chapter 3 and talk about 3.3, which is dividing polynomials. Okay, so we've learned how to multiply them, add them, do composite functions. So now we're going to learn how to divide polynomials. Okay, so first look at this example. So if it's pretty similar to dividing integers. So we know that 10 divided by 5 is equal to 2. So if I multiply 5 on both sides, it's 10 is equal to 2 times 5. So, just like we can do that with integers, is we can write this. Let's say we had starting from this, we would have something like x minus 1 times x squared plus x plus 1. So if we multiply that all out and simplify the terms, I'm skipping some steps here, you get x cubed minus 1. Okay, so the idea is that we want to think backwards. So here we multiplied it, but this also means that if I divide both sides by the quantity x minus 1 and flip around the equation here, I get that x cubed minus 1 divided by x minus 1 is x squared plus x plus 1. Okay, so we're going to learn techniques to find this right hand, or find this polynomial and this polynomial here. Okay, so first we need to talk about what we call these here, or some terminology. So, for example, if you had x cubed minus 2 over x minus 1, the dividend is x cubed minus 2. The divisor is x minus 1. So if we do this, so notice how this is x cubed minus 1 over x minus 1 divides into another polynomial. But if I do x cubed minus 2 over x minus 1, this is actually equal to x squared plus x plus 1, but minus 1 over x minus 1 when x is not equal to 1. Because if x is equal to 1, we have a division by 0 in here and here. Okay, so we say that the remainder is negative 1. So this right here, right? Because this is really, you could rewrite this as a plus negative 1. Right? So it's whatever, so the divisor here, x minus 1, this negative 1 here is called the remainder. So the dividend is what the numerator, basically the divisor is the denominator, and then the remainder is is the remaining thing. It's like when you have 9 divided by 2, that's really, right, 9 divided by 2 is equal to, it's equal to let's see, 8 plus 1/2, which this is going to be 2 times 4, right? So 4 2's fit into it, and then we have a remainder of 1, so it's 1/2, and 2 is the divisor there. Right, okay, so how can we, how do we learn how to do this process for long division, now that we've got the terminology? So it turns out there's a theorem, or there's a division algorithm. So an algorithm is just like a process of how to do it, right? So a polynomial is divided by a polynomial f of x is divided by d of x, where d of x is not 0. Then we can, if this is the case, we can write f of x over d of x equal to another polynomial q of x plus r of x over d of x. Right? So this is, so like in this example up here, we had one polynomial, so this would be f of x divided by d of x, and then it equals this q of x here, this polynomial, plus a polynomial -1. It's just a very simple polynomial, -1 over our divisor here. Okay. So we also have to have that the degree of r x is less than, or strictly less than d of x. Okay, so it can either be 0, right? Like sometime in this example, when we had x cubed minus 1 divided by x minus 1, we didn't have an r of x because there's no remainder term, right? Because we have just a polynomial left over. And when we did it this way, this term, this polynomial here plus this term is not a polynomial because we have a fraction, right? This would be x to the -1 power. So this whole thing is not a polynomial, but this is a polynomial, -1 is a polynomial, and this is a polynomial. So it either fits where r is 0 or less, a polynomial with degree less than the divisor. So for example, since our divisor here is x minus 1, the degree of the divisor is is 1. So the only possible degree polynomial we can have here is a 0-degree polynomial, which is any constant. Okay. So now that we have our algorithm here, we will go ahead and do an example. So again, it's always best to see these general type things and then do a couple examples to understand what they really mean. So if they, for example, wanted us to find, oh, and so this here, one more term I need to introduce, quo. The quotient is x squared plus x plus 1. So the quotient is, right, q, right here. That's what the quotient stands for, the big capital Q. Okay, so find the Find the quotient and remainder. When 2x squared plus x to the fifth plus 7 plus 4x cubed is divided by x squared plus 1 minus x. So that's an example that they have in the book. Okay, so the first thing you want to do is identify the dividend and identify the divisor. So from our example before, we're going to have the dividend is this piece here, and the divisor is this piece, because that's just what the problem is. That's the directions of the problem. Okay, so we're taking the divisor and dividing it by we're taking the dividend here and dividing it by the divisor. So with that being said, it's always useful to write your dividend in descending, like, so write them in order. So the highest degree term plus the next one. So sometimes it's also convenient to write 0x to the fourth, right? Because there's no x to the fourth term here. Plus 4x3 plus 4x cubed, sorry. 4x to the third plus 2x squared plus 0x plus 7. That's the dividend, written in a descending order. Okay, so then the divisor we also want to write that way, except now the divisor is only degree 2, so we've got quite a bit of zeros. And again, this 0 thing you don't have to do, but it's when you see this process for the first time, sometimes it's helpful. Plus x squared minus x plus 1. So now you want to take and rewrite this here. So I guess you don't really need to write out the divisor this way. So if you look in the book, I'm going to teach you a slightly different way than they're doing it here. So I always write it like this. There's the dividend, and then here I'm just going to write this one as x squared minus x plus 1. Okay, so just like long division, you're going to think the algorithm of long division here with numbers, but here we're doing it with polynomials instead. So remember, with long division, you would always see, okay, how many of these can I fit into my dividend here? So in this case, you're kind of thinking the same thing. I'm going to take what do I multiply by this top term here to get x to the fifth? So if I multiply, and then I'm going to record it. So if I multiply this whole polynomial by x cubed, right, then if I distribute it here, right, if I just kind of lightly draw this, I'll erase this in a second. If I multiply this by x cubed, I would get an x to the fifth for the first term, and then distributing it out, I would get a couple other terms. But the most importantly is you need to look at the first term. Okay, so if I multiply by x cubed and record that down, then it's going to be the first term multiplied by x cubed is again x to the fifth. Then this one is negative x to the fourth, and then plus x cubed. Okay, and then plus a bunch of zeros, right? So then here's where we take our line, and just like we draw our line here to subtract this term off like we would do in like we would do in long division. So we take this polynomial and subtract this polynomial. We've already done subtracting polynomials here. So x to the fifth plus 4x plus 2x squared, 4x cubed plus 2x squared plus 7, you just have to combine like terms. So we have an x to the fifth, and then remember we're subtracting off a positive x, so this is 0. And then we have 0x to the fourth minus a negative x to the fourth, so this is plus x to the fourth. Then we have a plus 4x cubed minus a positive 4x, regular x cubed, so we just have plus 3x cubed. And then here we have like, actually we can fill this in too. You don't have to do this again, but it sometimes helps. Right, so then we have 2x squared minus 0, so plus 2x squared plus 0x plus 7, since we're not subtracting anything off those last couple terms. Okay, so then after this step, you have another polynomial. So you know you're done when the degree of this polynomial down here is less than the degree of this divisor, or it's 0. Okay, so let's continue on here. So if I again do the same process, what can I multiply x squared by to get x to the fourth? Well, it's x squared. So in that case, okay, sorry about that. So if we multiply the x squared, if we multiply our polynomial by x squared, the leading term would be x to the fourth. So I again write down on the bottom line what I want to subtract is multiplying this polynomial by x squared. So I can get x to the fourth, and then minus x cubed, and then plus x squared. So now I'm going to subtract this off, so it's, right, minus. So we get a 0 here, and you're subtracting off a negative x to the x cubed, so it's going to be plus 4x cubed. And then just plus x squared, because we have positive 2x squared minus x squared. And then plus 0x plus 7. Okay, so we're still not done, because we still have a power, our degree on this polynomial that we've just produced here is still greater than our divisor's degree. Okay, so I need to add another. So now I not only do I need to multiply by another x, because I only have x squared in the leading term, but I also need to get the correct coefficient going here, which is a positive 4. So I need to now multiply by 4x, so I can get 4x cubed when I multiply 4x by this polynomial here. So minus 4x cubed minus 4x squared plus 4x. Okay, and so the next line, so now we have a 0 plus 5x squared minus 4x plus 7. Okay, so the degrees here are now equal, which means we'll only have one more step to do. So if we divide these two by each other, then I need to get my x squared leading term to be looking like a 5x squared, so I would multiply by 5. Okay, so this would be minus 5x squared minus 5x plus 5. And we get 0. Negative 4x minus negative 5x is like negative 4x plus 5x, so we get a plus x and plus 2. Okay, so now we are done, because the degree here is less than our divisor's degree. So this is actually what our remainder is going to be. So so some people say deg in parentheses is less than deg d of x from our definitions earlier. Okay, so we this and what happens is this is what your Q is. That's your quotient. So to answer the question, it said find the quotient and the remainder when you divide 2x squared plus x to the fifth plus 7 plus 4x cubed by x squared plus 1 minus x. The quotient is x cubed plus x squared plus 4x plus 5, or in other words, what you get on top of your long division symbol. And the remainder is what you get left over when your degree of the polynomial is less than the degree of the divisor. Okay, so let's go ahead and do another one. Okay, so another long division. So this one just says directions here change. So it just says divide x to the fourth minus 13 x squared plus x plus 35 by x squared minus x minus 6. All right, so we've done this, or so we, in the last round we actually did what we're about to do. The directions were find the quotient product. So now they're going to expect you to write out what the quotient and remainder together. So if we do set up our long division here, we get x squared, whoopsies, x squared minus x minus 6, x to the fourth minus 13 x squared plus x plus 35. Okay, again, so we start off the process by looking at the first we also noticed that it gave us the thing the two polynomials in descending order, so that's good. So now I look at the leading coefficients, right, or the leading terms. So those are the terms in the polynomial that have the highest degree or have the highest exponent. And here we look at the x to the fourth term, and here we have the x squared term. So what do I need to multiply this polynomial by to get its leading term to be x to the fourth? Well, that's x squared, because if I multiply x squared by x squared, it's x to the fourth. So we have x squared, or x to the fourth, then x squared times negative x is negative x cubed. So notice here I'm writing this top one without those zeros filled in this time. And then I get a minus 6x squared. So now we're combining like terms here. So we have an x to the fourth and a negative x to the fourth, so that's a 0. So we have a 0x cubed up here, right? There's no x cubes, but then we have a plus x cubed down here, so plus x cubed. Now we have a negative 13x squared minus a negative 6x squared, so it's negative 13 plus 6, which is negative 7x squared. And then, so that's it for our terms in the being subtracted off, so we just have plus x plus 35. Okay. Right. Okay, so now I take this the degree of this polynomial is still bigger than the degree of this polynomial, so we need to keep going. So now I look at the leading term here and the leading term here, and it's what do I need to multiply this polynomial by so that the leading term is x cubed? So just positive x. So it's x cubed minus x squared minus 6x. We subtract that off. So we would get 0. Negative 7x squared minus negative x squared is negative 6x squared. X minus negative 6x is plus 7x, and then we have a plus 35 left over. So our degree on this polynomial is not smaller than this degree yet, so we need to keep going. So here I have a negative 6x squared in my leading term, and here I have a just regular x squared, so I need to multiply that our divisor by negative 6. So I have a negative 6x squared plus 6x, and then minus 30. Oh, it's actually plus 36. Okay, so now we subtract again. So negative 6x squared minus negative 6x squared is 0. 7x minus 6x is just x. And then here we have 35 minus 36, so minus 1. So now the degree here is less than the degree of your divisor. So this is the remainder. And this is the quotient. So remember, a couple minutes ago I wrote f of x is equal to q of x plus r of x over d of x. So we're going to fill this in. So f of x is this divided by this divided by this, and that's what they want us to write. So we need to just fill this in. So it's equal to f of x, x to the 4th, minus 13, x squared, oh sorry, plus x plus 35. This should be f of x over d of x. Let me rewrite that. That's a little messy. Yep. So this is just from a couple pages ago. So it was f of x over d of x. There we go. So it's x to the 4th minus 13. If I'm just filling in what we've found using our algorithm here, plus x plus 35 divided by x squared minus x minus 6 is equal to q. So q x squared plus x minus 6 okay, and then now we have to add the remainder, which is x minus 1 divided by the divisor, also here, x squared minus x minus 6. Right, and it's just like numbers. If I had instead, right, 9 divided by 2 is equal to 8 plus 1/2. So 8 would be the quotient, and 1 would be the remainder. Here's the divisor. Okay, all right. So that's good. We learned how to do. We've done a couple examples of long division of long division to divide polynomials. So now let's learn another method called synthetic division. Synthetic division. Okay, so synthetic division works when d of x is equal to just simply x minus a. So for example, the last example we did, this would not work because that's not the last example. The last example we did, our d of x was x squared minus x minus 6. So it's not in the form x minus a because it has an x squared term in it. And the term in front of the x has to be 1 when you're using synthetic division. Okay, so let's just go ahead and walk through the process here. So it's just another way of doing long division. So if you did long division on these problems, it would still work. So divide, and you know what? For practice, I'm going to write long division here. So we're just going to do this problem both ways. So this first way is going to be using long division. So we would divide 2x to the fourth minus 3x squared plus 5x minus 63 by x plus 3. So the long division method, remember, it's the method we just did. X plus 3, you write your divisor here. Your 2x, you write your dividend here. Your f of x plus 5x minus 63. And your quotient is going to pop up right here. So what do I need to multiply this term by here? Well, I need to multiply a 2 and then x cubed. 2x cubed. So 2x cubed times this polynomial. The first term is 2x to the fourth minus plus 6x cubed. Right. Okay, so now I subtract this off and combine like terms. So these cancel, and you get a negative 6x cubed, because there's no x cubed terms up in the dividend, and then a negative 3x squared, a positive 5x, and a negative 63. So I still have work to do. This divisor is or this polynomial's degree is bigger than our divisor. All right. So continuing, we see that again this degree is larger than the divisor's degree, so we have to then multiply by negative 6x squared. So we get a negative 6x squared, x cubed here, minus 18x squared. Hi, kitty cat. Okay, sorry for all these pauses. Anyway, so back to the point here now, we have to subtract this off. And once you subtract this, we get a 0, a 15 x squared plus 5x minus 63. Okay, so so now we take, this is still a higher degree polynomial, so we need to take we need to multiply by a 15x squared. I'm sorry, 15x up here. So we're going to multiply this polynomial by 15x, so we get plus 15x squared plus 45x. Okay, so now we can subtract this off, and we get a 0, a 50x. I don't think that should be 50. Exactly, this should not be 50 because it's 5x minus 45x, so minus 45x, and then the minus 63. I'm sorry, so it should be minus 40x. 5x plus negative 45x is negative 40x. Okay, and so now we're at the same degree, so we still have to do one more divide, so I would multiply this by negative 40, and then we get a negative 40x, and then a minus, it looks like a 3 times 40 is 120. So we subtract this off, and the 40x's go away, and you get a negative 63 plus 120, so it should be 57. Okay. So that means that we would have, our final answer would be 2x to the fourth minus 3x squared plus 15x minus 40 divided by x plus 3 is equal to is equal to the quotient. So 2x cubed minus 6x squared plus 5x, plus 15x minus 40. And then we have to add the remainder plus 57 over x plus 3. Okay. So there's your answer. That's how you do it with long division. Okay, so now with synthetic division, our new method, again, this only works when your leading or your divisor is in the form x minus a. So this works because we're dividing by x plus 3. Remember, it's 2x to the 4th minus 3x squared plus 5x minus 63. Remember, it's being divided by so a would be negative 3 because this is equal to x minus negative 3. Okay. So the way that synthetic division works is you copy down the coefficients. So, for example, here we've got people usually draw a little box right here, and then they copy down the coefficients to our dividend. Coefficients of our dividend, so we'd have a 2. And notice that we skip x cubed, so we have to enter in a 0 here for the x cubed. Otherwise, this doesn't work. It's a very common mistake. Minus 3x squared plus 5x minus 63. So we've got our coefficients copied down. So next, we have to, and then we're going to leave a space here for some other numbers to go right here. Alright, so you have to figure out what a is. So I already gave that to you. So if you're dividing by x minus a, you put a in this little box. So a goes here. So a, in our case, is negative 3. All right. So we filled in that box, and now it's time to fill in this method. You just basically fill in the lines under. So the first thing you do is you bring the first number down. So you have a 2. Then you take a look at the second, or you take this number here, the 2 that you've pulled down, and you multiply it by negative 3 to get negative 6. So 2 times negative 3 is negative 6, and that's what you put to the box up and over. Okay, then you add these two numbers. Add, so 0 minus 6 is negative 6, and bring it in and write the sum in this set right next to the 2. Okay, so again, now we repeat this process. So negative 6 times negative 3 is positive 18. Then we're going to add negative 3 and 18, so this is 15. Now we take 15 times negative 3 and write it up here. And we keep doing this process. 5 and 45 is negative 40, and negative 40 times negative 3 is 120. So here we add these two numbers and you get 57. So this should look familiar because it's just a quicker way to do polynomial long division, and these are some of the same numbers we got there. Anyway, so now we've got these numbers, and it turns out that your last number here, the last number, is the remainder. Okay, so the remainder, so the remainder in this case is always going to be a number because you're dividing by a first degree polynomial. So the degree of your remainder has to be less than the degree or 0. Okay, so it's only going to be a constant, so it has to have 0 degree or it's got to be 0. And these numbers now are just your coefficients to these leftover four numbers are coefficients for the polynomial in decreasing order. So since this one was fourth order, and we're dividing by a first order divisor here, we would expect that our quotient q is going to be third order. So this is going to be 2x, or one less order than the dividend. So this is going to be 2x cubed minus 6x squared plus 15x minus 40. So that's equal to q. And then the remainder, so r of x over d of x is equal to 57 divided by x minus negative 3. So it would be, the answer would be 2x cubed minus 6x squared plus 15x minus 40 plus 57 over x plus 3. So that's how this is a much quicker way than going through all this. So we just did that same, so look, yeah, we get, wait, this is not the, where's that example? Yeah, so here, this is our work from the long division without synthetic division, and we got that answer. And it's the same as our other answer, but with much less work. Okay, so synthetic division can save you a lot of time. Okay, the next thing we need to talk about is something called the remainder theorem. So again, I cannot stress this enough. The synthetic division only works when your divisor takes this form. Okay, and this is where the remainder theorem comes into play too. If a polynomial f of x is divided by x minus a. So again, the divisor has to be x minus a for this theorem to work. Then r, since when we're dividing by x minus a, our r is always going to be a number. So it's no longer r of x, it's just a number. It's just a constant. So you could say r of x, but it's just a constant. So it's actually just equal to the polynomial evaluated at a. So if you think about this for a couple minutes, you can figure out what the remainder is of a polynomial without doing any of the division. So if someone just is going to ask you, if I divided 2x to the fourth minus 3x squared plus 5x minus 63 by x plus 3, what would my remainder term be? Well, you could just say, oh, I know how to figure that out with the remainder theorem. I could just plug a into the polynomial rather than dividing it. Okay, so let's try using that. Let's try using this theorem, see what exactly I'm saying here. So let's say f is equal to f of x is equal to 2x to the 5th minus 4x cubed plus 5x squared minus 7x plus 2. Okay, and it's divided by x minus 1. So first, in order to use this remainder theorem, right here, we need to figure out what a is. So a, and we have to check if we can use it even. So remember, a has to be in the form, or your divisor has to be in the form x minus a. Well, we have it because it's x by itself with a coefficient of 1 minus a number. Again, if it were x plus 1, your a would just be negative 1 because you can rewrite that as x minus negative 1. But here we have it already written in the correct form. So a is equal to 1. Check. All right, so now if we want to know what is r, we can use the remainder theorem because now we just do f of a, which is equal to f of 1. So that's just evaluating this polynomial up here. So that's going to be 2 times 1 to the 5th minus 4 times 1 cubed plus 5 times 1 squared minus 7 times 1 plus 2. Okay, so this is going to be a 2 minus 4 plus 5 minus 7 plus 2. So if you add all that up, that's 2 minus 4, negative 2, plus 5, positive 3, minus 7 is negative 4, plus 2 is negative 2. So that's what r is equal to by remainder theorem. Okay, so that's kind of a neat little thing you can do here. So what if, so here's one of these multiplications that you would never, or long divisions you would never want to do, nor would you have time. So find the remainder without the remainder theorem of find the remainder term where f of x equals x to the 110th power minus 2x to the 57th power divided by x minus 1. So the reason why you would never want to do this with synthetic division or long division is in the synthetic division case, remember when we wrote out, let's see if I can bring that back. So for example, when you copy down your polynomial, so we had a degree 4 polynomial, so we needed 1, 2, 3, 4, 5, one more column than degree. So the problem with a synthetic version is this is a degree 110 polynomial. So you would need to write out 110 columns to do that and also compute 110 things. The same thing happens in the long division because if you had, here for long division, I have a degree 4 polynomial here that I'm dividing by x plus 3. So I had to do 1, 2, 3, 4, multiply and divides, or multiply and subtractions. So for a degree 100, polynomial, you'd have to do that 110 times. For degree 110 polynomials, you have to do that process 110 times. So if someone just asks you what the remainder term is, in this case where we have x minus a, we're going to go ahead and not do the actual division like we could have here and figured out the remainder. We're going to just use the remainder theorem. So a is equal to 1. So I would just have to do f of a, use the remainder theorem. See here, this equal sign is the thing that requires the remainder theorem. Okay, so this is equal to 1 to the 110th power minus 2 times 1 to the 57th power. by the remainder theorem. These two are equal. So then r is equal to 1, because 1 to the 110th is just 1, minus 2, which is equal to negative 1. So r equals negative 1. Okay? The remainder theorem kind of, if you want to, there's a proof of it in the textbook, in the chapter, in section 3.3, if you wanted to look up how the proof is. It's actually quite, it's not too hard of a proof. And if you have any questions about it, just let me know. But that's how you would use it. Or that's one way. You can also use it going the other way. So the other way of the remainder theorem would be for a problem like this. So let's say little f of x, you're given this function, x to the 4th plus 3x squared minus 5x squared plus 8x plus 75. Find f of 3. So, I mean, obviously one way you can do, in the way we have been doing this, is what if I just take this 3 and just plug it in to where x is? Well, that's fine. That's actually correct. But you could use the remainder theorem if you wanted to. So if we use the remainder theorem, we know that r is equal to f of a. So a, if they want us to find f of 3 by using the remainder theorem, we would say, okay, if I want to figure out what f of a is by using the remainder theorem, by just finding a remainder of, I need to figure out what I need to divide this thing by to get f of 3. So if I want to get f of 3, I need to divide by x minus 3. Okay, so you can do this with synthetic division too. So we'll go ahead and do it with synthetic division for more practice. So if I want to divide x to the 4th plus 3x squared minus 5x, so this should be a 3x squared, cubed I mean, x to the 4th plus 3x cubed minus 5x squared plus 8x plus 75 divided by x minus 3 with synthetic division. So again, we draw the box up here and we put a in there, so this time it's positive 3 because it's x minus 3 and not x plus 3. And then here we have the coefficients, the 1, 3, negative 5, 8, and 75. So here we have no zeros because it's a degree 4 polynomial and it has all of its it has all non-zero terms. Okay, so now we begin the process. So here's our line. So we bring the 1 down, multiply it by 3, and you get a 3 here. Add these up. 6 times 3 is 18. This is now 13. That's 39. Oh, okay, here, hold on. I gave a slightly wrong problem. They want you to actually figure out what f of negative 3 is. So we should actually divide by x minus negative 3, or x plus 3. So that would change, remember a goes into this box here. So let's restart. Okay, so 1 times negative 3 is negative 3, so that makes a 0. 0 times negative 3 is a 0, so this makes a negative 5. 3 times negative 5 times negative 3 is 15. Adding these together, that's going to be a 23. 23 times negative 3 is negative 66. Okay, so the last one here, wait a second. No, not 66, negative 69. And the last one here is going to be, so if we add these two together, we get a 6. So then we know that it's going to be a third order answer because we start with a fourth order. It's going to be, well, we're just trying to find the remainder, and we actually can just say that 6 is the remainder. So by the remainder theorem, f of negative 3 which we just found is equal to 6, but by the remainder theorem, that's equal to r. I'm sorry, we found that 6 is equal to r. Said that the wrong way. 6 is equal to the remainder, and that's, by the remainder theorem, equal to negative 3. Okay, so now we're going to talk about one more thing. That's how you can use that remainder theorem in synthetic division. So the last thing we need to talk about is the factor theorem. So f of x is a polynomial, has x minus a as a factor, if and only if f of a is equal to 0. So this goes both ways. If f of a is equal to 0, then you can cleanly factor with no remainder x minus a out of f of x. And if, you know, we've been doing factoring all semester so far. So this you know, just like multiplication and division are related, you would expect that factoring and dividing polynomials would be related as well. Okay, so using the factor theorem. So that's our next example. So we have given that 2 is a 0, right? Remember, if it's a 0, then x minus 2. If 2 is a 0, then x minus 2 is a factor. We learned that in the last chapter. Is a 0 of the function f of x equals 3x cubed plus 2x squared minus 19x plus 6. So given that 2 is a 0 of the function f, solve the polynomial equation. Um, 3x squared plus 2x squared, sorry, 3x cubed, I keep doing that. 3x cubed plus 2x squared minus 19x plus 6 equals 0. So they want to know what are the roots of this polynomial. Well, they've already given you one. So if they give you one, they say that 2 is a root, so, or is a 0. So using this is a degree 3 polynomial, so it could have 3 roots. So instead of trying to factor it, they already give you a factor. So we're going to go ahead and we're gonna do long division so that we can get this down to a degree 2 polynomial, which are much easier to factor. So we're going to take this and divide it by x minus a, or x minus 2. So we're going to do, and we're doing synthetic division because we have an x minus a. So right, the factor theorem tells us that x minus a is a factor. So if I divide this thing by x minus a, I should get a polynomial with no remainder. Okay, so I use my synthetic division here, and I write the little box. So a is going to be 2. And we copy our coefficients down here. So we have a 3, a 2, a negative 19, and a 6. And here's our line. So we bring the 3 down, multiply by 2, you get 6. Add these together, you get an 8 times 2 is 16. Negative 3 times 2 is negative 6, and these add up to 0. Remember, this is your remainder. So what we have, the quotient, is 3x squared plus 8x minus 3. So that means that, remember, that means that plus the remainder, but the remainder is 0. So it's saying 3x cubed plus 2x squared minus 19x plus 6. plus 6 divided by x minus 2 is equal to 3x squared plus 8x minus 3. Okay, but now let's multiply both sides by x minus 2. So we would get 3x cubed plus 2x squared minus 19x plus 6 is equal to x minus 2, and we're not going to distribute it, times 3x squared plus 8x minus 3. Okay. So now we can write, we can write this step here to solve this equation. We've already factored out this x minus 2, and we just now need to factor this quadratic, which we know how to do. Okay, so remember, when we're factoring the quadratic, we need to look for the product of a and c, a quadratic with a non-1a coefficient. So we need to look for the products of a and c, so that's going to be -9. And then we need to get, we need two of these factors that sum to +8. So I would probably choose +9 and -1. So then we have, this is going to be x minus 2. And then we want to group this other one here. Since we have 9 and 1, we want to go 3x squared plus 9 plus 9x, and then minus x here. And then we have a minus 3. Okay, so now we factor an x out of this term, actually a 3x, so 3x times x, so this is multiplied here, x minus 3, right? That's what you have left over if you pull a 9x out of these two. Hey. I'm almost done with this problem. This is the last problem. Okay. Sorry. Sorry about that. Okay, so we have x minus 2 times 3x times x minus 3 minus, or plus -x. So I'm going to factor out the negative here too. Minus x plus 3. And, sorry, this should be a plus here. Okay, this is just the factoring by grouping method that we learned. Okay, so now, if we continue, we have x minus 2, and now we're going to pull out this x, we're going to factor out this x plus 3 from this last term. So it's going to be an x plus 3 times a 3x minus 1. Okay, so then if we wanted, so we started with this here and divided it by x minus 2 to get this quotient, and then we factor this quotient. So we factor that beginning polynomial all the way. So now we know that these two expressions here, this in its factored form is this. So if we wanted to solve this equation, we just set this equal to 0. So that would mean x minus 2 is equal to 0, x plus 3 equals 0, and 3x minus 1 equals 0. So you solve all these independently. So this is x equals 2, x equals minus 3, and then you add 1 and divide by 3, so it's x equals 1/3. Okay, so that would be how to find the zeros here of your equation. These would be the answers. Those are the solution sets. So if I plug in 2, I'll get a 0 on this side. If I plug in -3, I'll get a 0 on this side. And if I plug in 1/3, I'll get a 0 on this side. Those are the 3 numbers that make it happen. All right, that's all for today, and I will let you guys go until tomorrow.